KN6TKO Oscar. He will guide us through the world of understanding digital radio. Ladies and gentlemen, please put your hands together to welcome on stage Steve Shack, Kilo number 6, Tango Oscar.
Okay, so my name is Steve Shack from Santa Barbara, California, call sign KN6TKO. Can everybody hear? Yep, okay. So digital radio was mentioned, but I'm actually specifically talking about FT8 and with FT8, and nowadays because of the sunspot cycle, 6 meters, 50 megahertz. Next slide. So this is just the topics. I'm going to try and keep it to 20 minutes or so. There is technical and non-technical stuff here, so because there's probably no time for questions, if there's technical stuff you're interested in, I'm happy to chit-chat about it. There's a whole lot of stuff to talk about, and it's not all going to be in here. So anybody that's interested in more details, please let me know. Next slide. So I used to listen to WWV and WWVH. Those are the time frequency standard stations in the United States, Colorado and Hawaii. And I was a 12-year-old just absolutely enthralled, and I would listen to these things and learn about propagation because WWV and WWVH operate on like 5, 10, 50, 20 megahertz. And one of them is in Hawaii, and it has a different, has a female announcer, and one in Colorado has a male announcer, and you can listen to shortwave radio on any of the bands and hear, you know, which one is coming through, and is it coming through from Colorado or is it coming through from Hawaii? Anyway, then that took me into ham radio world, and I mostly HF, and I had a VHF handy that is like 3 times the size of what I'm seeing here, so it used to be really big. Then around the mid-90s, I lost interest in ham radio because I could go on the internet and talk to somebody 10,000 miles away. That was using the Gopher protocol, which was before HTTP, just FYI. And then 2 years ago, I just was so flabbergasted with how cool things are nowadays with software-defined radios and digital modes like FT8. So I got back into it. Next slide. So FT8, I'll just try to go through a little bit. Digital mode, 1s and 0s sort of characters, data, named after the guys that invented it, Steve Franke, Joe Taylor, and it uses modulation technique 8FSK, it's frequency shift keying. Next slide. All right, next slide. So FT8 uses a SSD voice channel, even though it's not really a channel because you can park anywhere on a radio spectrum and, you know, next slide. So this is actually a spectrum scope that I got off the internet of the 20-meter HF band, and that 3,000 hertz is at 14.074 megahertz. That 3,000 hertz is what you would normally need to have a voice conversation. It's actually a little less than 3,000. Next slide. Now, FT8 is only getting 50 hertz, so not 1,000 hertz, not kilohertz, but 50 hertz. And so that means lots of FT8 conversations and QSOs can fit into one SSD voice bandwidth. Next slide. So that's an example of a bunch of FT8 conversations seen on the waterfall display in an FT8 software program. Each of those red rectangles is a transmission for 15 seconds of data, and it's somebody saying, hey, CQ, or, you know, here's my signal report, here's my location. Next slide. And this is what it sounds like when it goes over the air. I have to do this here. Oops. This is what an FT8 signal sounds like. So that goes on for 15 seconds, and then it's half duplex. So what happens is one person transmits, and then that goes for 15 seconds, and then receives for 15 seconds, goes back and forth. Next slide. So typical setup. Next slide. Hardware. Any PC device, Mac, Raspberry Pi, Linux box, transceiver, and an audio interface. Next slide. So this is just an example of a PC connected through a USB audio interface into what looks like an Elecraft HF rig. Next slide. These are transceivers that a lot of folks are using for FT8. The one on the left is, I think, from qrpeer.com or something. It's a 1 watt, 1 band radio, and people are using that for FT8. The one there is the two in the middle are Xiegu from China, and those are commonly used. Those are about 5 to 10 watts, I think. The one on the right is a micro SDX, 8 band, and it's 3 to 5 watts, I think, 3 to 5 watts. Again, FT8 compatible. In the US, the one on the right goes for $140 on Amazon, so 11,000 rupees. Probably add 30% duty if you want it here. Next slide. That's the sound card. So there's, they call them sound cards because it used to be a card that would go into your 8086 PC. But USB audio interface, and that's strictly to take the data from your computer as audio and push it into and out of the transceiver. Next. Okay, and then software. Program that people use for FT8 is most commonly WSJTX. I think that's named after the inventors. I can't remember their names, but that's on SourceForge, open source. There's another one called JTDX, and I think there's others even. But that, next slide. So the purpose of that software is threefold. So send and receive audio to your transceiver, communicate with the transceiver's command functions to turn it into transmit mode and back to receive mode. And that's done in various ways. A common one is with the voice-operated transmit setting. And of course, conducting QSOs with FT8. The software takes care of the QSOs. Next slide. Next. So this is an example of an entire FT8 QSO. So one back and forth conversation. And so the first, basically everything in the pink or magenta is one ham operator. Everything in dark blue is the person on the other side of that QSO. And what's happening is it's strictly sending these very short sets of characters to establish the minimum pieces of information that would constitute a QSO. And I'm not sure if everybody here knows QSO. It just means a contact that's a back and forth and acknowledgement. But basically you're just saying CQ and you're sending your location, and I'll get to that in a minute, but a location, every ham can say that they're in a certain grid square location. And so my home grid square is DM04, and actually, to get real specific, you can add on more characters, so mine is actually DM04DK. And then the other person, when if they want to answer the CQ, their software, which by the way WSJTX will automatically answer the CQ, sends the grid square, and then the signal report is exchanged when it's in decibels, and then Roger 73. That's it. So a lot of people, there is some controversy that this is just too robotic. Sometimes they call this like zombie QSOs. Anyway, next slide. This is an example screen from the WSJTX software, and it's just to show that on the left is what WSJTX is decoding from that audio spectrum of 3,000 hertz. that one SSD voice channel. It's pulling every little conversation every 15 seconds and displaying it in the left window. And you can see in this example that I just grabbed off the internet, there's whoever's here has got tons of different different countries at far distances. Next. So the really cool thing, there's a couple cool things we'll find out that I think are cool anyway about FT8, and one is that it gets through long distances at very low power, and so QRP and DX, right? And QRP typically means 5 watts or less. Some might say 10 watts. And so DX, oftentimes too, it means long distance, but oftentimes also it's perceived as international. So I think that's a great thing about ham radio, is going international, and people can say, yeah, I talked to some guy in this other country. They're not all bad. And sort of good vibes. Next. Okay, so when you're going long distance at low power, obviously your signal might be extremely weak. And so what's super cool about FT8 is the software such as WSJTX has got really fancy mathematics going on inside of it to extract the FT8 tones, I'll call them, the data, from the noise that it pulls off of that SSD voice channel. So it's barely audible data, sometimes in the noise you might call it, can be extracted strictly because there's a whole lot of fancy mathematics happening in that program. And even more, 10 years ago, the decoding, the extraction, and the signal processing might have taken 20 minutes for every 15 seconds of data. The processing speed is so much better nowadays. Next. So here's an example from my QTH, 5 watts with a car antenna on the floor indoors, going more than 12,000 kilometers. And I didn't even try to do anything fancy with the antenna. I just stuck it on the floor nearby, inside the house. And so Japan, Australia, South America, and then most of the East Coast. One thing that's kind of cool is you can notice that the signals on the east side of the United States there's nothing from the California side where I was until you get, a third or a half the way across the country. So you're actually seeing the radio signal not land and not be detectable until it's gone up and back down further away. So it's sort of like seeing the radio waves, and you'll see more of that here. Next. Here's another one that I got off the internet, and I thought this was awesome. So somebody in southern India, VU3UKN, this is, I don't know if that person's here. I don't know what wattage, but imagine this, more than 15,000 kilometers to Argentina. That was 30th of August, and we are in the middle of a sunspot cycle, so you're going to find this kind of thing happening more often over the coming year or so. Next. Okay, so you notice I was talking about 12,000 kilometers from me and 15,000 from southern India. That's all calculated because of the grid squares that I was talking about. So everybody, they find out their grid square, transmit it as part of their FT8 QSO, and that WSJTX software will calculate the approximate distance in kilometers or miles. Next. So before you go into FT8, you want to find your own grid square, and that's doable with lots of different websites, but one is on qrz.com, and this is a thing where you can actually zoom in and point at a certain spot and it'll tell you your grid square, or if you get your latitude and longitude from another website, you type it in there and then it generates a grid square. So NL42PK was I think the middle one. Anybody that's familiar with South City Mall or Acropolis Mall, that's in Grid Square, NL42EM. Next. So this next thing is what totally is awesome. PSKreporter.info. So those little lines that show the path are all because of the software like WSJTX sending received information that it pulled off or extracted from the signals, including call sign, signal level, grid square. It calculates all that stuff. And then it plots it on a map, and it even makes it searchable. Next. So by making it plotted on the map, it's making radio signals pretty much almost visible. And this just blows me away. Maybe folks, born recently aren't going to think much of it, but as a ham from way back, this blows me away. So next. So just getting a little further into the making propagation visible, there's a common way that people look at propagation conditions as predictions or whatever. And one of them's on QRZ.com, so next. So a lot of folks probably know about this. This is like, I think, updated daily. And if you look at the bottom left where there's a yellow arrow, this is sort of like telling you on whatever day you viewed this or visited QRZ.com that, okay, on 12 meters or 10 meters, daytime propagation, meaning how far your signal will get, fair performance, and nighttime poor performance. Now compare that to the next slide, where I don't have to go to QRZ.com. I can just say to PSK Reporter, show me everybody in my grid square where they are reaching and on which bands they are reaching. So this is all within the last 15 minutes. So whereas that other propagation forecast tool with the poor and the fair, that was a prediction for the day. This is like the last 15 minutes of actual radio signal transit by band. And the red, if I'm not mistaken, is 6 meters. That's 50 megahertz. Going 12,000 kilometers on 50 megahertz is absolutely fantastic. I recommend anybody that wants to get into HF to do it quickly because of the sunspot cycle that we're in, solar cycle 25. Makes it possible to use these high frequencies like 6 meters, 50 megahertz to go that far. But you can also see the yellow, there's an orange that's 15 meters, yellow is 20 meters, so 14 megahertz. So this tells me that, if I wanted to go to South America, at the time I was looking at this, if I wanted to reach somebody in South America on FT8 or even voice, then it's probably likely that I could get on the 14 megahertz band, and if I had my antenna pointed right, maybe make a contact. Next. Oh, and by the way, all this stuff, here's a specific, this is 10 meters, because with PSK Reporter, you can say, just show me 10 meters. The previous slide was just saying, show me everything. But basically, this stuff is visible because there are just so many people running FT8. And if there wasn't that many people, you wouldn't be able to see a really valid example of current conditions. But this, again, this blows me away. This is just people from my grid square, and I just said, show me where everybody is reaching on 10 meters. And this is, to me, this is insane. All through Oceania, East Asia, South America, entire United States. Anyway, I think that's awesome. Next slide. Okay, some more examples. You'll find that this is what's so cool to me, is being able to visualize stuff. Next. So this one, I just think is bizarre. And Imagine if, and this was me with the antenna in the room on the floor. All my signals lined up in a diagonal line on the east coast of the United States. That was so freaking bizarre. So I finally said maybe it's a weather front, and I overlaid with Photoshop a similar thing from windy.com, and sure enough, there was a big weather front about 500 miles to the west of that line of reception reports. So it's just amazing because what that told me is this weather front was actually taking my 10-meter transmissions and forcing them to land 500 miles away at some diagonal thing. Anyway, that blows me away. Next. Here's another one that shows where I was reaching the middle of the United States and the far east coast. And what that tells me is, because there's not much going on between the middle and the far east, is that my HF signal was hopping twice. So that's really cool. And next. Some people talk about riding the gray line. And so PSK Reporter can overlay, the day-night thing. So this gray shade is the nighttime coming through. And so you can see that 10 meters from my location was going towards Japan plus towards South America quite a bit. And again, those are all reception reports, so I didn't actually have QSOs with them, but I probably could have if I had called CQ more and stuff like that. The other interesting thing, this shows my antenna radiation pattern. So anybody that's into like the homebrew concept and maybe not building a transceiver, but maybe you want to make your own antenna, this told me that I think I was using an end-fed half wave pointing in a certain direction, maybe towards the east. But the end-fed half wave also has a forward and a back as well as broadside. So anyway, it's cool for somebody that wants to do homebrewing and tune their antenna or try out a vertical antenna versus a horizontal or a dipole. I really recommend this method because there's just so many reception reports that you can get in a very short amount of time. Next. Again, antenna radiation pattern example. So it kind of shows a right angle. So I forget what the antenna is here, but it's just the idea that whatever was being used had propagated or was able to dispatch its radiation at right angles. Next. And there's so much more to FT8 than what I've mentioned, but I'm going to say that there's additional programs and stuff that make FT8 even better. So next. So Grid Tracker is for people that want to basically, it's kind of like work all states or something, I think. Maybe you want to have a QSO with every freaking grid out there. The other thing is this is kind of cool because if you have WSJTX running on your PC, you just load this one and it talks to WSJTX inside your PC. You can get a little pop-up or a beep when somebody answers a CQ. The other thing is I noticed that when you run this, your presence can be announced to folks that are looking to make a QSO with your grid square. So you have more likelihood of getting somebody to answer a CQ just by using Grid Tracker. Next. So FT8, again, some people call it like a zombie mode because all it's doing is sending that CQ and grid square and then grid square signal report 73. These JSA call and VAR-AC are very much similar to FT8 in that they're doing good signal processing on the data so that the weak signals can get through, but it's keyboard to keyboard, so it's closer to a chat. So keep that in mind for anybody that's interested in EMCOM, emergency communications, over HF typically. So just like you might need to have an emergency communication link on VHF through a repeater or DMR or something, JSA call and RAC make it possible to utilize this weak signal and low power capability of FT8. Next, this is just a screenshot of JS8 call, just to show you it's similar to WSJTX. Next, and it's at js8call.com. And VARAC dashboard, VARAC-radio.com is where it's located. Next. The interesting thing, apparently a lot of people are taking their transceivers for repair because they overheat. So what FT8 is doing, when you're using FT8, it's putting out a full volume SSB signal, which is different from talking with a voice over SSB, because a voice, there's pauses and there's volume changes. So what happens is the transceivers or transmitters can get very hot very quickly, and so this is where people need to know that they probably shouldn't operate FT8 at the full 100 watts that a 100 watt transceiver might be capable of for SSB. And so that peak power level, typically called PEP or peak envelope power, typically you wouldn't go anywhere near that if you're doing FT8. Next. So there's a ton of FT8 videos and tutorials on YouTube that'll cover a lot more good stuff than what I've talked about here. But I recommend it if you've got the time and the patience to work with it, because it's great for seeing your signals, it's great for home-growing antennas. It'll let you learn about vertical antenna takeoff angles and antenna radiation patterns. And in Solar Cycle 25 means it's also really a great time to get into HF in general and FT8, especially because you can see how the sunspot cycle is really making long distance happen really well. Really, really well. That's why the 15,000 kilometers and stuff. And I think that's it. Next. That's it. Thank you.